Hello, everyone. Today we're going to be looking at prediction models for movie popularity. So many models are made for these. They've improved over time. So we're going to be analyzing all of these and how certain models are better than other models and how they reduce uncertainty and whatnot. So first, we're going to be talking about how do we define popularity, because obviously this is a very loose term. Is it box office? Is it ratings? Is it views? Is it streams? Is it um, awards? So obviously you've heard of Rotten Tomatoes, IMDb, but this sometimes investors aren't really looking at that. Most of the time, they only care if the movie's going to make money. Is it going to draw in viewers? So there's a lot of models that try to predict for that. So yeah, it's really important for investors to make smart decisions about which movies they should invest in, because a lot of the times they'll use these prediction models, and the more accurate they can be, the more certain they can be about investing in a movie that they'll get their money back. And especially for distributors as well, which movies should they distribute? Even after the movie is made, they're like, okay, well, now we have even more features we can take a look at, not just the script, not just the cast, and we don't have to predict what the movie's going to turn out to be because we already have seen the movie. But even then, how are you going to know how well it plays into the market, right? You can't just go off personal preferences. So in that sense, they go off a lot of past films and use these past films to create even better models for figuring out what theaters they should distribute it into. Should they go to Netflix? Should they go to Hulu? Will it play better on HBO and whatnot? So let's take a look at some previous prediction models. So the most um, primitive of them, I'd say, like this is one of a famous quote by Will Smith. He when he was looking at movies with his manager and deciding which movies he should be in, and because obviously actors need to decide as well if a movie's going to be successful or not. They don't want to really go into a flop. So he took a look at the top 10 highest grossing movies of all time and noticed that 10 out of 10 had special effects, 9 out of 10 had special effects with creatures, and 8 out of 10 had special effects with creatures and a love story. So in that sense, obviously these are just three predictive features that he used, but even then he got a pretty good sense and seemed to have worked out for him. Other prediction models can be more comprehensive, obviously, when they look at movie features. So there's this company which we'll be talking a lot today. It's called Epigox. Epigogix, I don't really know how to pronounce it, but it looks at scripts and makes recommendations on changes based on how many certain scenes, locations, archetypes, character types, and all these things there are in the film. But not only will it recommend to make changes on the script, it'll also recommend where a movie should be played and how much money it'll make, so how much we should market it as well. For one film, software recommended reducing the number of scene locations, decision that not only would likely increase box office, but it also accounts for decreasing production costs. So it's very it gives a holistic view in that way. So companies like Epigogix can also inform agents and managers whether their actors should take a role or not, as it predicts a movie's success. So um, prediction models have also historically been used for recommendations for audience members. So, for example, Netflix, and I'm sure HBO, Hulu also do these. They make recommendations to users based on that movie or TV show attributes like genre, tone. If you've ever been on Netflix, you'll see it recommends you a movie, like recommended for you, and you're like, oh, actually, that looks pretty good. And because with these linear regression models, they found that customers like you, that they'll like their recommendations about 10% better, or half a star on their 5-star rating system, um, better than their own selection. So that's really interesting. So, but prediction models now have even improved much more than these prediction models in the past, and actually a lot of studios are starting to take these into serious consideration. For example, Epigogix predicted the movie Lucky You in 2007. It starred Drew Barrymore, an established director-writer, and it was about poker, which was a pretty popular thing at the time. It predicted it would be a box office flop, and that it would only make 7 million on its budget of 50 million. And surprisingly or unsurprisingly, it was drawing in only 6 million. So it was actually really, really close. But over time, prediction models have even increased to better uh, methods, such as machine learning and neural networks, have improved even more than Epigogix and other linear regression models. These are more advanced. They take into account more features, such as support vector machines, or SVM for short, which we'll be using, or neural network features, neural network models, or random forest models. These are now most commonly used to predict box office ratings and on popular movie sites such as IMDb. For example, random forest models work by asking yes or no questions, for example, and like splitting each answer up into a new, as you can see here, a new node, and then that goes down the list, and then the final leaf of that forest can be used to decide whether that will be whatever you're measuring for, whether it'll be successful on the IMDb scale, Rotten Tomatoes, or box office, or whatever. So, since consumer behavior and market dynamics are extremely complex and unpredictable, certain areas of improvement may not lie just in categorized or quantitative features such as amount of name cast, the plot, genre, budget, but rather, and this is rather unexpected, visual features. So these features, such as movie trailers and posters, are extremely specific to the actual movie and marketing campaign. So it may be even more useful for in future research to improve accuracy. A recent so certain ground has actually been made on this front already. A recent 2019 study used CNNs, which are basically neural networks that are more specific, convolutional neural networks, and SVMs to find that the poster image was actually the most important feature for popularity prediction, while trailer duration was the most important feature for rating prediction. And interestingly enough, these CNN-based models outperformed SVM models in predicting movie popularity, while SVM-based models were more effective in predicting movie ratings. And we actually don't know why this actually is, but I'm sure if you dug into the actual methods, you'll see why one is better for predicting a certain type of popularity, while the other is better for another one. But hybrid models, including other metadata like genre, cast, and etc., usually perform the best. So, in other words, the more predictive features in the model, the better your accuracy will be. Although you kind of have to correctly and very precisely weigh these features, of course. Furthermore, some areas of improvement right now are not in the models themselves, but rather the lack of data available. So when time series data of days, weeks, months, and quarters become available, related investment and other decision making will greatly be benefited, because certain movies, of course, generate more revenue during certain times of the year, whether it's a holiday movie, summer movie, or Oscar movies, and whatnot. So sources of uncertainty can be measured. We're going to be taking a look at how sources of uncertainty now can be measured by seeing the difference between predicted box office and the actual box office, or predicted IMDb rating, or the actual IMDb, or whatever you're studying for, right? And averaging all these differences for all the movies studied. So this can also be described as the RSME, which is short for root square mean error. So a recent 2022 study found that SVM models are actually most accurate in predicting box office receipts in China and the US, having the lowest mean and standard deviation RSME out of all the models. So these uncertainties can be reduced by including more factors like blending a hybrid of visual features we described above, or changing the model altogether, right? So, for example, as we've seen here, uncertainty can be reduced by switching from a random forest model, which has a pretty large standard deviation and mean RSME, to an SVM model, which has a relatively smaller standard deviation and mean RSME. Accuracy can be evaluated by analyzing the difference between the predicted and the actual, as we described. But we're going to take a look at a few historical examples of how certain models did in these cases. So, for example, as we stated earlier, Epagogix predicted the 2007 movie Lucky You, which is projected to make by the public to make much more, to flop, which it actually did. Another famous example in 2004, where in 6 cases, Epagogix guessed the number of American homes that would tune into a show within just 0.06%. And in 13 of these 16 cases, its predictions were just within 2%. And so, for example, these percentage points can also be used to compute how much error these prediction models produce. Just like RSME, standard deviation, these are all different ways to show how accuracy is computed. Although Epagogix can be pretty off sometimes, especially for low-budget films, for working just off a script, the company gets pretty freaking close. So for one shocking example, Epagogix was given a studio script analysis in which almost everything they suggested in Hollywood terms was small. They wanted the lead to jump off the page a little more. They wanted the lead to have a younger sidekick, a relatively minor character to connect with a younger demographic, and they wanted the city where the film was to be set to be much more of a presence. So all these factors then, the neural network put the potential value of better characterization for each of these factors at an extra, let's say 2 million. I don't know the exact numbers, but we have it here: 2.46 million for the U.S. box office revenue. The value of the location adjustment at 4.92 million, and the value of a sidekick at 12.3 million. And so the value of all three of these together was an extra 24.6 million. So that's just another 25 million basically for a few weeks of rewrites and maybe an extra day or two of filming. So um, basically, they said if you didn't make these changes to the script, it would make only 47 million. And these changes weren't made, and it made 50 million. So it was pretty close on that one as well. Um, so lastly, how are these prediction models communicated to the public? So often, I don't know if you're on Variety or Deadline or any of these big news companies, they use a lot of modern machine learning models and recent news and sentiments and whatever to constantly report these box office predictions for the public for opening weekends and whatever. So they also report whether predictions were correct or not using headlines such as Gemini Man flops opening weekend or some sorts. So this is actually pretty good because it undermines their prediction legitimacy, which is pretty admirable of them, but also creates better content for their stories as people are curious to hear why a movie did so poorly or well or whatever. But it's good because they report on all their failures and successes as well. So, but I wouldn't say these specific models are actually really communicated well. It just shows like they're mostly like, here are the results of what our models say of how much it's gonna make opening weekend. It doesn't actually really communicate to the public how these numbers are computed. Um, and So I'm curious to hear how like Variety, Hollywood Reporter, and Deadline get their predictions, and because I'm sure smaller and more savvy tech companies that reach much less people are doing a better job in terms of creating less uncertainty for their models. In this sense, we should constantly be looking for new ways to reduce mean RSME in machine learning models and finding new predictive features and weighing which features matter most to reduce uncertainty in our predictions. So, although these prediction models obviously aren't perfect, they've gotten really, really close, and it affects investment and affects the way stories are told in interesting ways, and it has a lot of impacts also on the future of how AI can create movies as well, because already machine learning models are being used to inform how films are being created to maximize whatever box office ratings or whatever you're trying to maximize. So it's large implications, and I think it's going to go pretty far for better or for worse. Thank you very much.